Good day, everyone. You're welcome to ChemTube. And in today's class, we'll be looking at chemical combination. And under chemical combination, we'll be looking at covalent bonding. Okay, remember we have different types of chemical bonding. We have the ionic bonding, and then we have the covalent bonding. Then the covalent bonding is divided into two. We have the ordinary covalent bonding, and then we have the dative covalent bonding. But in this class, we'll be looking at covalent bonding. Now, what is covalent bonding? Covalent bonding involves the mutual sharing of electrons between two non-metal or between a non-metal and semi-metal. So, covalent bonding involves the bonding between two non-metals. When you have two non-metals coming together, and the bond between them is called covalent bonding. Or if you have a non-metal and a semi-metal, the bond between them is called covalent bonding. And the name of the compound formed is called covalent compound. So covalent compounds are usually gaseous in nature. For example, you have oxygen gas, O2. We have nitrogen gas, N2. We have CO2. And then we have CH4. So all these compounds tend to have what we call covalent bonding. So all right, so here is a periodic table. In the last video I did about ionic bonding, I differentiated, I helped you to understand better examples of metals and non-metals. So here is a preview of metals, and then we have non-metals. So all right, so most of the time, students tend to have problem to differentiate a covalent compound from an ionic compound. So simply put, so when you look at a compound, for example, you have CO2, and then you are asked what type of bonding is between them. Now, because carbon is a semi-metal, and oxygen is a non-metal, okay? So therefore, the bond between them is a covalent. Another example is if you have H2O. So this is between hydrogen and oxygen, okay? So since hydrogen is a non-metal and oxygen too is a non-metal, so the bond between them is called covalent. So let's see how we can form covalent bonding. So let's look at an example. So let's take an example of so now number one, I'm going to do covalent bonding between two non-metals that are the same. For example, oxygen. Let's start with H2. H2 is between hydrogen and hydrogen. And another thing you must understand about covalent bond is this. Now, when covalent bond is formed between two atoms, a covalent bond is actually formed between them. It can be a single covalent bond, okay? It can be a double covalent bond, or it can be a triple covalent bond, okay? So let's look at hydrogen gas, and let's see the type of covalent bond that is formed between them. So you have hydrogen. So hydrogen has this is the structure of hydrogen, please. So this is hydrogen. Okay, this is hydrogen. Now another thing you must understand is this. In bonding, the whole essence of bonding is for the atom to have what we call a covalent an octet structure, so or a duplet structure. So if you look at hydrogen has one electron in its atomic shell, and it needs one more electron for us to have a duplet structure. So what happens? So since hydrogen needs one and this one needs one, so they share with one. So they come together. When they come together, this hydrogen here will donate one electron, and this other hydrogen will donate another electron. So when you look at it, so this is the bond between them. So this 2 electron is both for this hydrogen and for this hydrogen. So the number of electrons for this hydrogen is 1 and 2. While for this is also 1 and 2. So we have a single covalent bond. So and then this is the structure. So we have H and then we have H. Another example is oxygen. So let's look at oxygen. Oxygen will help you understand better. So for example, oxygen, O2, the structure of oxygen, O, is 2,6. and this other oxygen is also 2, 6. So both of them need 2 electron for them to have an octet structure. Okay, so the structure of this oxygen, the valence shell will be used. So this one has 6 electron in its outermost shell. Okay, this one has 6 electron. This is the oxygen. Then the other oxygen also have 6 electron in its outermost shell. Okay, now so remember they need 2 electron each. Now something that can help you is this. Now each oxygen atom would share with a number, they would both bring out electron to share. Okay, but how many electron? How do you know the number of electron that they are both to bring? Like in hydrogen here, they brought out one electron and they shared. So how do we now know the number of electron they need? So the number of electron, or what determines the number of electron they need is, or they will share with, is the number of electron they need. Now since both of them need 2 electron each, they are going to share with 2 electron. So therefore, let's start with this oxygen. So we have this oxygen. It brings out 2. First of all, you write out the 2 it is sharing with, 1 and 2. Then out of the 6 electron it has brought out 2. So you write the remaining 4. 1, 2, 3, 4. Now the other oxygen also, it needs 2 electrons, so it's going to share with 2. Now I'm going to do something like this: 1 and 2. So just to differentiate it. So since this one is also bringing 2, so it will also remain 4. Out of 6 it brought out 2, so it will remain 4. So write out the 4. Okay, so this oxygen brought out these 2, and this oxygen brought out these 2. So we are going to have, you pair them, so we have 2 and then we have 2. So you can see, if you count the number of electrons for each oxygen, for this oxygen now you are going to have 1, 2, 3, 4, 5, 6, 7 and 8. While for this one also you have 1, 2, 3, 4, 5, 6, 7 and 8. So you can see both of them have 8. But if you check, the number of covalent bond here is 2. We have this and then we have this. So we have a double covalent bond between the 2 oxygen atom. Okay, so now let us now try. Now if I may ask you, okay, let's try for nitrogen gas. If I may ask you, okay, a nitrogen gas is between 2 nitrogen atoms. So we have N, which is 2,5, and then you have another N, which is 2,5. Now if I may ask you, how many do nitrogen need? You will tell me it is 3. It needs 3 for it to become octet. This nitrogen also needs 3 for it to become octet. So if I may ask you, how many electrons would they share with? Would each of the nitrogen share with? So because of it needs 3, it's going to share with 3. Likewise, this is also going to share with what? 3 electrons. So you are going to have okay, let's draw the structure first. This is nitrogen. This is the valence shell having 5 electrons. Okay, 5. This is the nitrogen, and this is also nitrogen having 5. Okay, so this is nitrogen. So they both need 3. So because they need 3, they would share with 3. Remember, they share with what they need, with the amount they need. So we have this nitrogen. Okay, so this is how you draw the structure. You write, bring out the 3. 1, 2 and 3. That is for this nitrogen. So when it brings out 3, it will remain 1 and 2. So this is the 5, but it is donating these 3 here. So likewise, this also brings out 3. Let me use star to differentiate 2, and then you have 3. So after bringing out 3, it will remain 2. Okay, so we have nitrogen. So you pair it. This is a single covalent bond, another covalent bond, and then you have another covalent bond, making a triple covalent bond. So we have N, and 1, 2, 3, and then you have N. Okay, so if you count the number of electrons for each of the nitrogen, you are going to have 1, 2, 3, 4, 5, 6, 7 and 8 for this nitrogen. So for this you have 1 2 3 4 5 6 7 and 8. So all right, so there you have it. So that is covalent bonding for a gas of the same atom. So in the next video I'm going to do covalent bonding for compound like CO2 and CH4 and water. That is for compound where you have the element binding not being the same or being different. Right, thank you very much for watching this video. Do have a nice day. Bye.